Hello, my name is David Hopkins. I'm a master's student at Memorial University of Newfoundland in process engineering. And during my master's, I was supervised by Dr. Stephanie Macquarie of Cape Breton University and Dr. Kelly Hobbold of Memorial University. Today I'm going to present on my thesis, which focused on crab shell biochar as an effective means for removing copper from water. To introduce, the snow crab fishery is a very important part of the Atlantic Canadian economy. In 2018, it generated over $772 million. However, when we process this crab, it generates a lot of byproduct in the form of the crab bodies, which is a lot of shell weight in particular. And that catch weight, that can represent up to 30 to 50% of the actual catch weight. And this contains still a lot of valuable compounds that could improve process economics and decrease environmental footprint if we were able to recover them. Our potential solution that we'd like to present today is pyrolysis. So pyrolysis is a very simple thermochemical process which occurs in the absence of oxygen. From the diagram I have here in my methodology, we see that we have our biomass going into a furnace that operates between 400 and 600 Celsius that is continuously flushed with nitrogen gas so that there's no oxygen within the chamber. This produces three different products: a biogas, a liquid bio-oil. Both of these have very many specialty chemicals that could see other applications. And in addition to that, a solid residue, which is called biochar. In our study, we look at a biochar, and we're going to look at it from the study conditions of 500 degrees Celsius and 100 milliliters per minute of nitrogen. Solid biochar, in this case, is a potential adsorbent that we can use for acid mine drainage, which contains a lot of metals and is very acidic, so it has to be treated before it's released. In this study, we will characterize crab shell and discuss its use as a copper adsorbent in acidic solutions. We chose copper because it's a very common metal found in acid mine drainage. So from characterizing our biochar, we find that it's primarily made of calcite and has a high pH of 11.75 and a relatively high specific surface area of 20.71 meters squared per gram. That's important because if we have a high specific surface area, that allows us to have more sites for adsorption to be taking place, and the high pH enables us to reduce the acidity of any solution that we place the biochar into. Other biochar properties that we found were similar to calcite, which is already used in acid mine drainage treatments. Additionally, due to the production temperature of 500 degrees Celsius, we found that the biochar contains no or very little viral or bacterial contamination, which makes it useful because then we know that there aren't going to be many cases of contamination into the waters we're treating. Additionally, when we treat these synthetic wastewaters that we made with copper, we found that at a biochar dosage of 5 grams per liter, the biochar had an adsorption capacity of 184.8 milligrams per gram, and that's about 40 to 99% removal, depending on the concentration you use. Additionally, when we change the initial pH of solution, there's no effect on the amount of copper you remove. And so that just shows us that because we're neutralizing the pH, the acidity of the solution doesn't compete with the adsorbent for metal adsorption, which is very useful. Furthermore, the adsorption capacity we find is much higher than commercial adsorbents and other types of biochar. I'd also like to show you these scanning electron microscope images that just show you between the left and the right. The right shows you all these new crystals that have formed from the copper adsorbing to the surface of the biochar. So it just gives you an idea of what's happening. So to conclude, we find that this biochar is a very useful metal adsorbent and highly effective. Future work is still needed to test other metal solutions which will have different chemistry and may behave differently. And we also need to test other the product streams from this process to improve feasibility by seeing the applications of this bio-oil and biogas. Finally, I would like to thank the NSERC and Ocean Frontier Institute, OFI, for their funding on this project, and to Louisburg Seafoods Limited for providing the crab bodies used in research. Thank you.